Now for third BTech students, for mechanical engineering students, we are dealing of fluid mechanics and hydraulic machinery, simply called as FM/HM. Mechanics of fluids, the behavior of fluids. We are dealing with behavior of fluids, and the applications of fluid mechanics is nothing but an hydraulic machinery. Okay, two topics: fluid mechanics as well as hydraulic machinery is going to study in third BTech first semester subject. One of the important subjects of mechanical engineering. Unit 1, we are discussing about the unit 1 here, about introduction of fluid mechanics. First two units is about fluid mechanics introduction, and the remaining 3 units is about the applications of fluid mechanics. That is about we are going to discuss later. The remaining 3 units about application of fluid mechanics. Fluid statics. We know that introduction of fluid mechanics. Fluid mechanics may be statics, kinematics, dynamics. Statics, kinematics, and dynamics. Prepared by Madhara, Professor, Mechanical Engineering. Topics covered in this presentation. What are the important topics we are going to cover in this presentation? Is about introduction about the subject. What is meant by fluid mechanics? What are various classification of fluid mechanics? Next is about properties of fluids. The major properties of fluids. The major properties of fluids we are going to discuss about density, specific weight, specific volume, specific gravity, problems on numerical problems or basic problems on properties of fluids. First, what is meant by fluid mechanics? We already know the mechanics. Mechanics is nothing but a branch of science which deals with rigid bodies, which are at rest or in motion. Similarly, what is meant by fluid mechanics means it discusses about the behavior of a fluids. The behavior of fluids which are at rest or in motion. Fluid mechanics is defined as the science which deals with behavior of fluids are at rest or in motion and interaction of fluids with fluids. Is a behavior which deals with the fluid of rest, the fluids at rest or in motion. We know that every fluid is contaminated in a container. Whenever it is contaminated in a container, they are interacting with the solid materials. The study of fluids at rest. We know that the study of fluids which are at rest is called as fluid statics. The study of fluids in motion. The study of fluids in motion where pressure force are not considered. Is called as fluid kinematics. That means the pressure forces are negligible. Whenever negligible, these are not to be considered. Those are called as fluid kinematics. Nothing but an dealing about the displacement, velocities, and accelerations of fluids. Those studies called as fluid kinematics. And if the pressure force are considered, if the fluid is in motion, where pressure force also considered, the branch of science is called as fluid dynamics. Branch is called as fluid dynamics, otherwise called as fluid kinetics. Next. First going to discuss what is meant by fluid. A substance exists. We know that the substance can be exist in three cases. Those are solids, liquids, gases. Solid, liquid, gas. A substance in liquid and gaseous case. What is meant by fluid means a substance of liquid and gas phase is referred to as fluid. A solid can resist an applied shear force by deforming. We know that solid having good strength, where the intermolecular space is very less. Whenever the intermolecular is very less, the strength is more. The solid strength is more. when applied it resists, the solid can be resist, but in case of fluids deforms continuously under the influence of shear stresses. The strength is very less viscosity. Whenever there may be less viscosity, the fluids can deform continuously under the influence of shear stresses. In solid stress, in case of solids, we know that Hooke's law. In solid mechanics, we study about Hooke's law, which is the stress is directly proportional to strain. Hooke's law, stress is directly proportional to strain. But in case of fluids, that is nothing but liquids and gas, the stress is proportional to rate of strain. The stress is proportional to the rate of strain. Nothing but rate of deformation. Now comes to the properties of a fluid. The first property of a fluid is about the basic property of a fluid is about density. Nothing but a fluid density. Otherwise mass density. By the figure we can understand what is meant by density. It is a weight. It is a container. Container consists of a liquid. The mass of liquid by volume of a liquid is nothing but a density. By the diagram also we can discuss. First, properties of a fluid. First, about density, otherwise called as simply called mass density, simply called as density. Density, otherwise mass density of a fluid is defined as the ratio of mass of a fluid to the volume of a fluid. Mass of a fluid to the volume of a fluid. It is denoted by a symbol of rho. It is a Greek symbol rho. It is denoted by a symbol of rho. Mathematically, units. The mass unit is kg and the volume unit is meter cube. Kg per meter cube is the unit of density. Mathematically, mass density is written as density is equals to mass of a fluid by volume of a fluid. Density rho is equals to mass of a fluid by volume of a fluid. Mass of a fluid by volume of a fluid. Mass of fluid is kg. Volume of fluid is meter cube. This is an important one. Kg per meter cube. Important to next question. Specific weight. Specific weight, otherwise called as weight density. On or before, it is mass density. It is weight density. What is the change means? What is the difference means? The ratio between weight of a fluid to the volume of fluid. In the previous, it is mass of a fluid to the volume of a fluid. Now, weight density is nothing but weight of a fluid to the volume of a fluid. Weight of a fluid by volume of a fluid. It is denoted by a symbol of small casing W. Specific weight is equals to weight of a fluid by volume of a fluid. Weight of fluid by volume of fluid. The units. The weight units is Newton. Volume unit is meter cube. Okay. Newton per meter cube is unit of specific weight, otherwise called as weight density. Weight density and specific weight both are same. The units are Newton per meter cube. Specific weight. The same specific weight we can write as specific weight can be written as. Here, the weight can be written as according to the Newton's law, Newton's second law, we can write as mass into acceleration. Right or wrong? The mass can be written as mass into acceleration of a body. M into A. Now I am writing the same here. Specific weight is equals to mass of a fluid by acceleration due to gravity. Mass into acceleration is nothing but weight divided by volume of a fluid. Specific weight S is equals to mass of a fluid. The acceleration due to gravity is denoted by symbol G divided by volume of a fluid. Now specific weight is equals to rho multiplied G. In terms of weight density, the weight density or otherwise specific weight in terms of mass density can be calculated is equals to rho into G, nothing but density multiplied with gravitation, where G is 9.81 meter per second square. 9.81 meter per second square. Next, specific volume. Specific volume is the ratio of the volume of a fluid to the mass of a fluid. Volume of fluid to the mass of fluid, nothing but an which is the reciprocal of density of a fluid. Which is the reciprocal of density of a fluid. That means the density of a fluid is mass of a fluid by volume of a fluid. Okay, specific volume means volume of a fluid by volume of a fluid to the mass of a fluid. That means specific volume is equal to volume of a fluid by volume of a fluid by mass of a fluid. Specific volume is equal to 1 divided by reversing, by reciprocaling we get as mass by volume. By taking this as denominator, we get as mass of a fluid by volume of a fluid. What is meant by mass of a fluid by volume of fluid is nothing but density, rho, 1 divided by rho. Now, can you guess what is the unit? The unit is, or simply called as, the specific volume is the reciprocal of mass density. Okay, simply it is defined as the specific volume is the reciprocal of mass density. Unit is, the unit of density is kg per meter cube. Now, unit of specific volume is meter cube per kg. Specific gravity. Specific gravity is defined as the ratio of weight density of a fluid to the weight density of standard fluid. Specific gravity is defined as the ratio of weight density of a fluid, weight density of a standard fluid. Okay. For liquids, standard fluid, the standard fluid is taken as water. For gases, standard fluid is taken as air. For liquids, both are fluids. For liquids, the standard fluid is taken as water. For gases, standard fluid is taken as air. Why? Because those are constant. Air density as well as water density are constant. That's why we are taken as, those fluids are taken as standard fluids. Specific gravity is also called as relative density. Why it is called as relative density means the ratio between both densities, weight density and weight density. Numerator is weight density, the denominator also weight density. The relation between the weight densities. Whenever the relation between the weight densities, it is also called as relative density. The specific gravity is also called as relative density. Denoted by a symbol of capital S. Capital S. Now dimension in dimensionless unit. Why? Because both are density by density by cancellation we get no units. There is no units for specific gravity. Now, specific gravity of liquids is equals to weight density, otherwise simply called as density. Both are same. Weight density of a liquid by weight density of a water. For liquids, we can take the standard fluid as water. Yes, for gases, the specific gravity for gases is equals to weight density, otherwise density of a gas divided by weight density of a air. Weight density, otherwise density, same density by density, otherwise weight density by weight density. No problem. Weight density of a gas divided by weight density, otherwise density of a air. For gas, the standard fluid is taken as air. Already discussed. Now, weight density of a liquid is equals to, from this equation, from above equation, the weight density of a liquid can be written as specific gravity S multiplied with weight density of water. By taking on that side, it becomes as multiplication. Now, S multiplied with 1000 multiplied with 9.8. We know that weight density of water is equals to rho G. Already discussed in the properties. Rho into G. Rho is the weight density of water is, it's constant. It is kg per 1000 kg per meter cube. G is 9.81. It is constant. The unit is Newton per meter cube. The density of liquid. Otherwise, by taking the density, without density, we are taking the relation between the densities. It is the density of liquid is equals to specific gravity multiplied with density of water. Density of liquid is equals to specific gravity multiplied with density of water. What is the density of water? The density of water is constant. I will discuss later. The density of water is constant. S multiplied with specific gravity multiplied with, it is 1000 kg per meter cube. S multiplied with 1000 kg per meter cube. The density of liquid is equals to, when you know the specific gravity, how can you find out the density means? When you know the specific gravity, how can you find out the density means? Density of liquid is equals to, we have to multiply it, simply multiply it with density of water, that is multiplied with 1000. Problem, first problem. Calculate the density, specific weight of 1 liter of petrol, specific gravity 0.7. Okay, we have to calculate density, specific weight, and the weight of a liquid. The 1 liter of petrol, the given fluid is petrol, 1 liter. The volume is given as 1 liter. We have the known quantities, specific gravity. Now, how can you solve the problem? Given volume of petrol, the volume of petrol is 1 liter. Whenever it is 1 liter, 1 liter can be written as, the CGS unit of 1 liter is 1000, that is 10 cube centimeter cube. 1 liter is equals to 1000 centimeter cube. 1000 centimeter cube can be written as, in terms of, I am converting in terms of meter cubes. Now it becomes 1000 divided by 10 power 6 meter cube, that is equals to 0.001 meter cube. Simply called as 1 liter is equals to 10 power minus 3, 1 into 10 power minus 3 meter cube. 1 liter is equals to 1 into 10 power minus 3 meter cube. Specific gravity. The specific gravity is given as 0.7. Solution. Density. We know that, how can you find out the density? The formula is, how can you find out the density? The formula is, density of liquid is equals to specific gravity multiplied with density of water. Why? Because the specific gravity is given. Now density rho is equals, we have to calculate mass density, otherwise density, simply called as density. Rho is equals to specific gravity multiplied with 1000. 1000 is nothing but standard water. Standard water density is 1000 kg per meter cube. The specific gravity is given as 0.7 multiplied with 1000. 0.7 multiplied with 1000 is nothing but, the calculation we get as 700 kg per meter cube. Next, specific weight W is equals to rho g. We know already discussed, the specific weight is equals to rho g. Otherwise, weight density is equals to rho g. Now this rho is 700 kg per meter cube. G is 9.81. We get 6867 Newton per meter cube. Next, where G is constant, we know that G is constant, acceleration due to gravity is taken as 9.81 meter per second. Now next calculation is about, we have to calculate weight of a fluid also. We know that specific weight, nothing but weight density. Specific weight is equals to weight of a fluid by volume of a fluid. Weight of a fluid by volume of a fluid. By that we get as, now weight of specific weight is 6867. Weight of a fluid is unknown, we get unknown. Weight of a fluid divided by volume of fluid is, we get as 0.001. Weight of a fluid W is equals to, by denominator we get as multiplication, 6867 multiplied with 0.001, get 6.867 Newton. Next, second problem. Next, calculate specific weight, density and specific gravity 1 liter of liquid, weight of 7 Newton. In the previous problem, specific weight is given. Now in this problem, the weight is given. By given weight and volume is given. Now we have to calculate specific weight and density. We have to calculate specific weight, density as well as specific gravity. Given volume of water, nothing but I have taken the liquid is taken as water here. The volume of water V is equals to 1 liter. Volume of water is equals to 1 liter means 1 into 10 power 3 10 cube centimeter cube. In order to convert into meter cube, 1 liter is equals to 1000 centimeter cube, that is equals to 10 power minus 3 meter cube. 1000 centimeter cube, that is equals to 10 power minus 3 meter cube. Now calculation we get as 10 power minus 3 means 0.001 meter cube. In case it given as 7 liters, it get as 0.007 meter cube. Next, the weight of a fluid W is given as 7 Newton. The weight is given as, comes to the solution. Specific weight W is equals to, we know that specific weight W is equals to weight of a fluid by volume of a fluid. Weight of a fluid by volume of a fluid. Why? Because we have to calculate specific weight. That is equals to 7 divided by, the weight is given as 7 divided by volume of fluid is 0.001, that is 7000 Newton. The specific weight is equals to 7000 Newton. Now density, we know that density rho is equals to, we know that specific weight is equals to rho g. Specific weight is equals to rho multiplied with g. From that, rho is equals to, rho is nothing but density. Rho is equals to weight density divided by g. Weight density divided by g. Weight density divided by acceleration due to gravity. We know that weight density is equals to rho into g. From that, we have to calculate rho. Rho is equals to weight density divided by gravitation constant, W by g, where g is acceleration due to gravity. It is taken as 9.81 meter per second square. Now density rho is equals to weight by g, that is 7000 divided by g is 9.81. We get 713.5 kg per meter cube. Specific gravity is equals to liquid, rho liquid by rho water. We know that specific, I already discussed, specific gravity S is equals to density of liquid by density of standard fluid. The standard fluid, we know that for liquid we can take it as water. The water density is 1000. Exactly, the water density is 1000 kg per meter cube. Now specific gravity is equals to density of liquid already calculated in the previous slide. It is 713.5 kg per meter cube. Now it becomes specific gravity is equals to 713.5 divided by density of water is 1000. We get as 0.7315. Specific gravity is equals to 0.7315. This is by dividing 1000. The specific gravity is always, the specific gravity is less than 1, less than or equal to 1 only. Is always, the specific gravity of is always points only. S is equals to 0.773, not less than 1. It is given, specific gravity is get as less than 1. By calculation by divided by 1000 it as 0.73. Specific gravity అనేది specific gravity ఎంత వస్తుందంటే by divide చేస్తే 0.7 వస్తుంది. 0.7315. Comes to characteristics. These are the points to remember, important points to remember about gas, liquid, solids. Gas within, what about the gas? What about the liquids and solids? Gases. The particles of a substance enough energy to complete overcome intermolecular interaction. Then the particles can separate from each other, move about the random in space. Whenever the particles of a body moves randomly, those are called as gases. That means the intermolecular structure is very loosely packed. Whenever that is loosely packed, those are called as gases. If the particles of a substance have enough energy to partially overcome the intermolecular interaction, when compared with gases, there may be a small intermolecular structure. There may be more viscosity. Compared with gases, liquids has some viscosity. That means the intermolecular bonding is more. The intermolecular bonding is more when compared with gases. Those are called as liquids. The intermolecular interaction, then the particles can move about each other while remaining in contact. Comes to solids. In solids, the individual particles of a substance are fixed position with respect to each other because there is not enough thermal energy to overcome the intermolecular interaction between the particles. The bonding of intermolecular structure is more in case of solids. When compared with liquids and gases, the intermolecular structure is more in case of solids. Solids have definite shape and volume. Solids have definite shape and volume, but liquids and gases depends upon the shape of the container. Liquids and gases depends upon the shape of the container, but solids consist of definite shape and volume. Now look at solid. The intermolecular structure is more, the bonding is more. Whenever the bonding is more, the strength is more. That's why it is called as solids. Liquids, the intermolecular structure is very less compared with the solids, very less. They are getting loosely packed. Those are called as liquids, which is adhere to the container, which is not adhere to the container. Which are adhere to the container, those are called as liquids. Which are flying, which are moving randomly, those are called as gases. By the diagram we can easily understand what is solid, liquid as well as gas. Important terms to be remembered here. What are the important terms means? The density of water is constant. Already discussed. I am going to discuss. Remember these things. The density of water is 1000 kg per meter cube. It is a constant one. Otherwise, in case of 1 kg is equals 1000 kg, 1 gram is equals to 1000 kg is nothing but 1 gram. That is otherwise called as 1 gram per centimeter. 1 gram per centimeter cube. 1000 kg per meter cube, or in case of CGS unit is 1 gram per centimeter cube. Weight density of water is constant. The weight density of water is also constant. The weight density we know that rho g 1000 into 9.81 we get as 9810 Newton per meter. Only we can remember this one only. We know G value is 9.81. Next, specific gravity of water is also constant. It is equals to 1. The specific gravity of water is 1. Look at here. The specific gravity of water is 1. Why? Because the specific gravity is nothing but density of liquid by density of standard fluid. Density of liquid by density of standard fluid. Now, density of standard fluid is water, and density of liquid is also water. By cancellation, we get S is equals to. Specific gravity of mercury is also constant. It is also constant because mercury is generally using in manometers. That's why we are taken as mercury. Mercury is constant. It is 13.6. There may be no units. It is 13.6, which is more. Mercury is also called as silver, solid silver. Okay, that's why it is more. The specific gravity is more in case of mercury only. When compared with water, mercury specific gravity is more. Next, applications of fluid mechanics. Fluids which possess kinetic energy as well as potential energy. We know that fluids possess kinetic energy as well as potential energy, which is used to generation of electricity in hydropower stations. In hydropower stations, the fluids are used to generate the electricity. Next, fluid mechanics helps to understand the behavior of a fluid under various forces at different atmospheric conditions. Fluid mechanics is used to understand. I will discuss the behavior of a fluids under various forces, various viscous forces at different atmospheric conditions. Next application. Fluids perform 3 crucial operations. We know that in automobiles 3 crucial conditions are there. Those are, it generates the power. Why? Because petrol, diesel generates the power. Nothing but a fluids. Generates the power. Lubrication, grease is also fluid. And also cooling the engine, water. We are using the water as a cooling. Now cooling the engine also we have used the fluids. This is the discussion about the properties of a fluid mechanics, and various applications of fluid mechanics.